Looking to bring the power of machine learning to your Android app? I'll show you how to get started with MLKit on today's Firecast. MLKit is a mobile SDK that brings Google's machine learning expertise to Android and iOS apps in a powerful yet easy-to-use package. Whether you're new or experienced in machine learning, you can implement the functionality you need in just a few lines of code. There's no need to have a deep knowledge of neural networks or model optimization to get started. I'd like to start out this video series on MLKit by showcasing one of the models provided by the SDK, MLKit's text recognition API for Android. You can use this API to recognize text in any Latin-based language. Text recognition can automate tedious data entry for credit cards, receipts, business cards, and more. I'm using a sample app from the Text Detection Code Lab for today's example. So if you'd like to follow along with the steps, you can find the Code Lab link below. At this point, I've already created a Firebase project, added an Android app to the project, and included the Google Services JSON in my project. If you're not familiar with these steps, you can check out the Getting Started Firecast, the Getting Started Guide, or follow the initial steps of the Code Lab. Ready? Let's get started. The Google Services plugin uses the Google Services JSON file to configure your application to use Firebase, and the MLKit dependencies allow you to integrate the MLKit SDK into your app. The following lines should already be added to the end of the build.gradle file in your app directory of your project. You'll see that there are other Firebase ML dependencies in this directory. We will talk about those in a future Firecast, but for our uses, you don't need them right now. To use the MLKit's text detection, this is the dependency we need. To be sure that all dependencies are available to your app, I sync my project with Gradle files. Now that I've imported the project into Android Studio and configured the Google Services plugin with my JSON file, and added the dependencies for MLKit, I'm ready to run the app for the first time. I start the Android Studio emulator and click Run in the Android Studio toolbar. At this point, I see a basic layout that has a drop-down field which allows me to select between 3 images. Before I add the code to my app to enable text recognition, I want to explain how the SDK handles it. First, I start with a bitmap of the selected image. Then, I initialize a Firebase Vision image object, passing the bitmap to the constructor. A Firebase Vision image represents an image object that can be used for both on-device and Cloud API detectors. From there, I process the image using Firebase Vision Text Recognizer, which is an on-device or cloud text recognizer that recognizes text in an image. I call Process Image on the Firebase Vision Text Recognizer, which passes the Firebase Vision image as a parameter. I use an onSuccess listener to determine when detection is complete. If successful, I can access a Firebase Vision Text object, which is recognized text in an image. I'll get into the details of this object a little later. Finally, I pass Firebase Vision Text from my onSuccess function to a function to process the text and display it on the screen. Let's see what these steps look like in code. I create a Firebase Vision image from the selected image. In my case, I've selected one of the 3 images, but the process would work the same for an image selected from taking a photo or from your photo library. Then I get an instance of Firebase Vision Text Recognizer. I disable my button while the image is being processed, and then call Process Image on the Vision image. Since Process Image is asynchronous, I add an onSuccess listener. When onSuccess is called, I'll enable the button again and call Process Text Recognition on the Firebase Vision text produced by the function. I'll also add an onFailure listener so I can handle if Process Image fails. For now, I'll just print the error. When I check out the Process Text Recognition result function, notice that it's rather empty right now. Let's talk about what this function does. In order to better understand how the process result function works, I'll examine the vision text object that was passed to the closure when I called textrecognizer.process. Firebase Vision Text has 2 functions for getting its properties. getText, which returns a single string of all the text recognized in the image, and getTextBlocks, which gets a list of type Firebase Vision Text.textBlock. A Firebase Vision text.text block is a text block recognized in an image. Think of blocks as paragraphs or groups of text that are similar. Text blocks have several functions for reading properties. Like Firebase Vision Text, they have a getText function for getting the recognized text of the block. They also have functions like getBoundingBox and getCornerPoints to indicate where the block of text is located in the image. There's also a list of languages recognized in the image and a float indicating the model's confidence level in the text. Also, we have a function called getLines, which returns a list of Firebase Vision Text.line objects. A Firebase Vision Text.line is a text line recognized in an image. Noticing a pattern here? You see Firebase Vision Text.line objects have similar properties to a text block. The difference is that they have a list of type Firebase Vision Text.element, which can be accessed using the getElements function. A Firebase Vision Text.element is a text element recognized in an image. An element is roughly equivalent to a space-separated word in most Latin script languages. So essentially, an element is basically a word. In many cases, you may just need the text of a photo, so you can just access it using the getText function of Firebase Vision Text. Other times, you may want to know the specific location of the words in the image, which is when you'll need to access the arrays of text blocks, lines, and elements. In the process text recognition result function, I want to label words over where they appear in the image. So I iterate through blocks, lines, and finally elements to find the specific location for each word. Text overlay may not be the use case for your app, but it's good to see how to iterate through those elements. Let's dive into the code for this. Okay, here I am back at process text recognition result. First, I get the text blocks from the Firebase Vision Text object. If no text is found, I display a message to the user that no text was detected, and then return out of the function. Then I'm clearing away any text I had previously displayed on the screen. Time to iterate through the blocks in the Firebase Vision Text. Then the lines, then the elements to get to the individual frames for individual words. Now I'm going to create a text graphic object with the text so it can be displayed over the image. I'm not going to go into the text graphic class right now, but if you'd like to see how it works, check out the code from the code lab, which I've linked below. Let's build and run the app so we can see some text recognition. Woohoo! It works! Congrats! You've now added text recognition capabilities to an Android app. Feeling inspired to make a new project with MLKit? I'd love to hear about it. Tell me in the comments below what you'd like to build with text recognition. And if you like what you saw here, be sure to like, subscribe, and share so you can be the first to know about new MLKit videos as well as the other great content on the Firebase channel. Thanks for watching, and I'll see you on a future Firecast.